NSA RF measurements webinar. My name is Alan Legaspi. I'm a field application engineer with Anritsu, and today I will be presenting and demonstrating Anritsu's RF measurement solution. So my agenda for today is to go over our MT8000, which is our 5G signaling test equipment, product information for frequency range 2 setup for millimeter wave, FR1 frequency range 1 setup for sub 6 gigahertz, FR1, FR2 control and synchronization, the MT8821C LTE Anchor, the MT8000 5G hardware configuration, test equipment configuration, a brief demonstration on our 5G NSA parametric measurements for FR1, a demo video on ATS. Now I want to go over the 8000 product information where we have slots 1 through 7, where here on the bottom are, here on the bottom are our RF slots, which are slots 1 and 2. In the middle, we have our baseband slots, slots 3 and 4. Here we have our data test module, which is slot 5. Here on the right, we have our multi-box data connection, which is our slot 6. And here, slot 7 is our control module, which allows our control PC to control the MT8000 itself. Now, on our RF slots, we have the ability to have support 0.4 gig to 6 gigs frequency, and we also have the ability to support 2.4 to 12 gigs. Now, our baseband modules here allows us to modulate our RF signal to give us a full 5G stacked signal. Here, our data test module allows us to take IP data from a server, from an IP server, which will pump this data into the IP server, giving us our IP throughput onto our device itself. Here on the bottom, we have our RF converter, which will up convert our RF signal from 28 gig to 43 gigahertz frequency. Now we support also theta and phi modulation for the vertical and the horizontal planes of measurements for millimeter wave. Here we have the MT8000 frequency range 2 setup for millimeter wave. On the left, we have our MT8821C, which will act as our LTE anchor. Onto the right, we have our MT8000A, which is our 5G signal. And we have our RF converter here in the middle, which will up convert our 5G signal to give us the frequency range for millimeter wave. We support phi and theta as previously stated, and this will be radiated, so you would need a RF anechoic chamber or shield box in order to enclose that signal where you're testing. Here we have the 8000 FR1 setup for sub 6 gigahertz frequency. On the left, again, we have our LTE signal with our MT8821C. Onto the right, again, we have our MT8000A for our 5G signal. And then here we have, under these ports, connected to either conducted to a device or radiated with some sort of chamber, some sort of enclosed chamber, where the 8821 will be giving us our LTE signal, and the MT8000 will be giving us our 5G signal. Now for MT8000, FR1, and FR2 control and synchronization, we're using a 10 megahertz clock in order for us to sync the two pieces of equipment together for our LTE and our 5G call boxes. Here in the middle, we have our MN8110B synchronization. This right here allows for the frame timing of LTE and 5G to be synchronized so that they're not stepping on each other. So if you're doing same band type test cases, that the LTE frequency and the 5G frequency are not interfering with each other. All of this is connected through Ethernet connection on the back of the MT8821C to a network or switching hub, and to the front panel of the 8000, which is also connected to a switch hub, and the control PC, which is also connected to a switch hub. And this control PC controls the LTE and the 5G. Here we have the configuration for the MT8821C LTE Anchor. This is the basic configuration in order for you to have this LTE Anchor. This is one component carrier, SISO configuration. And then here you would have a minimum configuration for the hardware configuration and software configuration required for NSA type communication. Now I wanted to show this picture where this is on the right is the actual 8000 call box that I will be using in my demo for today. Onto the left, it's showing the RF modules, baseband modules, data test modules, multi-box, and control. Where here on the bottom, I'm showing my slot 1, slot 2 RF modules from 0.4 gig to 6 gig on the top, and on the bottom will be 2.4 to 12 gig support on the bottom. Here in the middle are my baseband cards, which will modulate my RF signal to give me my 5G full stack signaling. Here on slot 5 is my data test module. And this orange cable right here connects onto my IP server, which is connected to a 10 gigabit Ethernet card to push as much data as required for the 5G throughput. And then on the top here is my slot 6 is my multi-box setup for protocol equipment to be connected together to give you that additional component carrier support that you're looking for with future products, future support. And here on the left is my synchronization, as well as my control to my Ethernet switch, so I can control my MT8000 itself. Now I actually want to give you a slide of the actual equipment that I will be using in my lab. On the left is our configuration for what it should actually look, what the spec or what our spec is to have this equipment to utilize. On the left is our LTE 8821C. On the right is our MT8000A. Here in the middle, we have a switch hub, which connects our 5G, LTE, and control PC all together. In this case, I am using my control PC here on the right as not only my automation test software computer, but also my control PC. The MT8821C for our LTE signal is right here on the top of my rack. It could be configured anyway. It doesn't have to be side to side like this. It could be in a rack formation. My MT8000 here on the right is right here on my bottom, which is labeled out. Both of which are connected to a DUT, device under test. Here on the right, I have my enclosement chamber for millimeter wave setup, which is mainly for protocol or just showing functionality of millimeter wave from an RF perspective, which is the MA8161A. Here I have my device under test, which is covered. It is an X50 device. Here I have my network switch and my control PC right here. Excuse the mess. Now for a brief 5G NSA RF parametric measurements, this will be for FR1. So when you first launch your application, your MT8000A application, you will get this type of GUI window. we allow for up to 10 configurations of software. So for our RF software, we have a lot of updates. We have updates just because of new features and things like that. So you can use an old build or a new build on the same GUI. So if you feel comfortable using with your device on a certain build, you can use that. Or if you want to use the latest and greatest with newer functionality, you can also use that as well. Now, this GUI allows for multiple pieces of equipment for us to use. We have other products, not only RF, but also like SSNR, which is our application tester, as well as RTD, which is our protocol tester. You can have all of this on one system. It's only divided by licenses. Now, once I launch my specific system that I'm looking to use, I will come up with an LTE window, which is ran by my MT8821C. And I will also have my 5G GUI, which will be ran by my MT8000A. First, we're going to go with the LTE window, which is MT8821C. And you can see all the various measurements here. So I update all my parameters here. Frequency information, level information, signaling information. Everything that I'm looking to update based on whatever network configuration I'm looking to mimic or try to achieve. My call processing information. I know it's quite a bit. TX measurements, RX measurements, fundamental measurements. But we do have a search feature so that you can not be intimidated by so many parameters. Where here we can do a search. I'm looking for, let's say RBs, and that shows me whatever functionality I'm looking for. It shows me 50 RBs under Umplik RMC, but it also shows a whole array of other items that I might be searching for. I like this quite a bit just because it's easy for me to find things, just because there's a lot of parameters. We also allow for SIM cards, SIM card configuration, whatever you're looking to use. Say you're using at Anritsu, we offer these specific SIM cards, which already have the security parameters already enabled, like the authentication key value, OPC, but you don't have to use, if you have another test SIM card, like a Verizon test SIM card, you can go ahead and use the user settings, and you could program in whatever your K value is, your OPC value, your integrity protection, and that allows you to have that specific SIM card, so you're not isolated to just Anritsu SIM cards itself. Whatever you do, always remember to save your parameters, to where if you change, let's say I'm going to change, here we have our frequently used screens, uplink channel. We have the ability to change this configuration. We have a range here. I'm going to change this to 20,000. And then I'm going to change, and then it automatically changes the band configuration. Transmit power control pattern is set to auto. You have the ability to change from down to all up. Channel bandwidth we support for LTE, mind you, 1.4 to 20 megahertz. Output level, you have the ability to change this out as well. Output level. Whatever you do, make sure to save your parameters so that you can recall it anytime. You can always come back to this once, if ever you make any changes, just for experiments. So I'm going to go ahead and save. Parameter save and recall, go to save. I'm going to call this test. Now I can recall that parameter file at any time. Now going here to my 5G screen, my 5G GUI, basically it's the same type of GUI information. So Anritsu designed the GUI of the MT8000 to be very similar to the MT8821C. So if you're used to the 21C, it's easy for you to go back and forth between the two without knowing how everything's configured. See here on the top, we have our frequently used items here. We have our common parameters. We have our general information. Here under RAN operation, we have the ability to select none, ENDC, and standalone. For none, we can actually select ARB files, as well as turning off our call processing so that we can have generated waveforms so that we can, for the ARF calibration group, you have the ability to use those ARF forms so that you can calibrate your devices, or even in the LTE system, you can do that as well. Here we have ENDC set for NSA state. Here we have the standalone state. All that's separated between ENDC and SA are licenses itself. You have the ability to change your general information, your cell information, your subcarrier spacing, depending upon whatever chipset, whatever your device is capable of doing. You have the ability to modify your bandwidths from 10 megahertz all the way to 100 megahertz. You have the ability to change your uplink, downlink channels, input levels. And again, you have the ability to do a search feature. So I'm going to search for modulation, and then it bounces me directly to uplink or downlink QPS modulation scheme. My device currently doesn't support 256 QAM, but I do have the ability to select 256 QAM. It's the reason why I'm selecting 64 QAM at the moment. You have the ability to change between QPSK 64 QAM in this case, which is what I'm currently doing. And you also have support of various measurements: occupied bandwidth, spectrum emission mask, adjacent channel power, in-band emissions, spectrum flatness, EVM, phase error, magnitude error, constellation. You can all do all this all in one screen. This is an all-in-one measurement. So when you start your call, do a continuous or single sweep, you would take your call, all those measurements instantaneously at the same time. Same thing with LTE, you could do that at the same time. Let me recall my parameter files, and then let's go ahead and get started on making sure we're able to establish a phone call. Right there, I'm able to recall previously saved parameters. I'm going to enable I just recalled my parameter files. I'm enabling my test cases. I'm also using a third-party tool called Visor as to connect to my device because I am working remotely as well. I'm going to take my device under test out of airplane mode. Establish my LTE call. I'm in idle registration. Also, I wanted to show you this as well, that we do have a state machine, which shows you the current state of your device. I'm currently in idle registration mode, as well as some signaling trace for the 4G side. And I'm able to establish my phone call. And now, in order to make my 5G call, I just have to start my call. I initiate my LTE call. Now I'm trying to initiate my 5G call, and now I'm in the middle of a phone call. Now I'm going to select continuous sweep, and it's going to take continuous measurements. And these are all of my current measurements. Let me adjust my input level. And now I'm in the middle of a 5G call. I'm able to take our parametric measurements. And also here on my LTE side, I'm going to do as well. I'm able to establish LTE measurements at the same time as 5G measurements. I apologize, I forgot to mention here on the right, we have our RF slot configurations as to where we are to connect our RF connectors. These RF connectors are up and down, so it will have input and output levels. Another cool thing that here is if you are doing automation commands here and there, say you want to change something like this, your LTE NR frame timing offset, you would come up to this top screen right here, drop down, and it would show you that specific command. Here, I'm going to blow up that picture here, another screenshot of our connectors from our RF side, from our RF slots. We also have the ability to take in external loss, where you would do a manual station calibration, and then you would save your CSV information, and then you would upload it based on whatever frequencies, and then you would port that into our system here, and would take that into account. For those of you that do station or do RF cal and are concerned and are trying to validate your test cases, test results. Here we have another powerful protocol tool. I know this is an RF setup, but this is our NR trace logging tool, which is able to receive message 1 through message 5. So if you are having issues with establishing a 5G call, we are able to provide you with a trace log tool, which can map out those specific functionalities. Another feature within this tool is we have the ability to take trace logs, or a logging tool, which allows us to save all internal logs in case you are having some issues here and there. We have the ability to take save all trace logs, and it will save information not only from the 5G side, but also from the 4G side, in which we can debug and try to trace what type of issues that you may be seeing. Let me go ahead and stop this. Start the call. You have the ability to as well go into one measurement screen, and you can determine whether you want to take a little more of a deep dive and seeing like spectrum emission mask and seeing more information here on the bottom. You have the ability to use spectrum monitor. You have the ability to take a look at multiple test cases, specific test cases, EVM again. Shows you a little more of a deep dive into this functionality. Here you have the ability to set your MIMO configuration, whether you want to be single antenna, 2x2 MIMO, 4x4 MIMO. Let me go ahead and close this out. And let me jump back into my presentation. Now I also wanted to show you our automated test software. This is a video demo, which I took just a couple days ago. This is just showing ease of use of our automated ATS test solution. Here we have ATS test tool. We're going to the plan editor. And within our plan editor, we're selecting our pieces of equipment to be used, which is our MT8000, MT8821. Now this is going to be an NSA test case. So we're going to be using both pieces of equipment. This is FR1 sub 6. Now we're going to go to the environment setting. We're going to be setting our switch configuration for pieces of equipment, our recall setting here. So if you have a saved parameter file, you can go ahead and recall that, or you can test everything from scratch. I would prefer to use a parameter file just because it's known configurations based upon what was previously tested, and then that will launch automatically. Here you have your anchor setting, your PLMN, your MCC, your MNC information, network information. You have here on the bottom your authentication information for your SIM cards. Again, under the SIM model, you have the ability to use any Anritsu SIM card here, or potentially like a carrier SIM such as T-Mobile, Verizon, where you would have to enter in that specific parameter yourself, but that is possible. Your algorithm, you can use XOR or Melange. You can populate your MC information here. And then here on the left, you have the ability to set your initial parameters. You can set power, input, output. You can select how many times you want to retry it. Path loss information, you want to use external or common parameters. External would be a manual setting. Common would be more of where you're doing a station calibration and using that info as to populate your loss information. You have the ability to set your slots for whatever slot you're testing off of, whether it be your R slot 1 or R slot 2. Here we have our test plan setting. We're setting E and DC parameters. In this test case, I'm testing interband, LTE band 1, NR band 78. And then within N78, I'm setting in my my subcarrier spacing information, my bandwidth, specific channel, for not only my NR band, but for also my LTE band. Here on the right, I'm selecting the 3GPP test case in which I would like to use. In this case, I'm using 6.3b.1.3. And onto the right, I'm specifying the modulation scheme